In this video, we're going to create a reinforced learning algorithm. So in order to do this, we are working in the reinforced Python workbook, which you can find at drstephpowers.github.io/BIA. And we're working on the reinforced learning here for prescriptive analytics. Prescriptive analytics is what should the organization do? Well, reinforced learning suggests to the organization the order that they should go in terms of the steps of the process, how to solve a structured problem. So let's look at how this works and let's go into the workbook. So again, if you click on that link, it'll open in GitHub. You can then open in Google Colab, save a copy, and then you can run through this code as well. All right, so we start by installing Gymnasium, and that's because in this case, what we're going to do is look at a simplified version of a problem, and we're going to look at what is called the frozen lake problem. So the idea is that you are in a location, a starting point on the lake, and there is the goal, the finish line you're trying to get to. And the thing is that as you move forward, backwards, left, right, you can move in 4 directions. There are holes in the ice. And so you want to get to that finish line without falling into one of the holes in the ice. So we're going to use this Gymnasium to replicate that game or that simplified activity. So we're going to need NumPy as NP, and we're going to need to import random because there is a random number generator in this process. And we're going to import Gymnasium as gym after we have installed it. We are also going to import something called tRange, so from tqdm. This allows us to see the little tracker bar to see how far we are in the process. So we're going to do from tqdm import tRange, and we can import matplotlib.pyplot as plt. I don't actually remember why I included that in here. Maybe at once I was going to graph something. Don't actually think it's needed. All right, so we're going to specify our environment. We have S for start, F for frozen, H for a hole in the ice, and G for our goal. So what we're going to do is we're going to use that gym package to make this frozen lake example. And if you're doing it in Google Colab, you're going to need this render mode ANSI to make it show up on the screen. So we're going to reset the environment to its initial stage, and then we're going to do print environment render. And so when we do this, it creates the image that you can see currently that shows we are currently at the starting point. It shows a 4x4 grid where the H's are the holes in the ice and the bottom right has the goal. Okay, you can go into this gym setup and you can change it so it's not just a 4x4 but an 8x8. You can also go in and actually set where the holes are in the scenario so that you can specify exactly what the lake looks like. So I encourage you to go and play with that. Now what we're going to do is we need to first specify the number of states and the number of actions. And so we're pulling from the environment the observation space and the action space and simply outputting it. What this shows you, at least in this default version that we've created, is that we have 4 actions: forward, backwards, left, right, or on our 4-dimensional grid, up, down, left, right are the moves that you can make. And then there are 16 states, right? If it's a 4x4 grid, there are 16 locations that we could be at in the environment. All right, so now we're going to do some setup to show how this works. So what we're going to do is we'll go through here 10 iterations. We'll reset the environment, so we start at start, and then we're going to go through this range where it's going to take an action, and that random action then is going to lead to a new state, so a new location. That new location has with it a reward, and if we fall into a hole, then the process is done or terminated. Otherwise, we can keep moving. So let's look at the process. So what this shows you here is that you can move left, up, and down. We can see it's moving us to different positions. If you are already in the position where you can't go up anymore, it doesn't do anything. If you're already in a corner, you can't go any further left. But it's showing you how it would move through and it would change the state, and then you can see the environment. That doesn't mean a whole lot to us just looking at this particular one. So let's move past this and look at the first version, which is the brute force method. So what we're going to do here is we're going to run through it 100 times. We're going to start with a array that is our reward array that is empty. And what we're going to do is look at the rewards as we move through the system. Now we're going to run it once, and then I'm going to add this little printout here so that we can see each iteration. So what we're going to do is we're going to loop through these 100 different simulations, and this T range in the code here is going to create a progression bar on the bottom so that we can track how far we are through those 100 different iterations. When we start the iteration, the loop, we start with our environment being reset. So we start at start, and we start with done equals false. As we move through this, if we fall into the lake, then done will be true and it will end, and we go to the next simulation. We loop through it again. Okay, so we're going to have a random action based on the action space, right? So that random action is that we can go up, down, left, or right. That is going to put us in a new space, and that space is going to be the new state, and we'll have a reward that is attached to it. And it could be that that particular state is a hole, in which case we're done. If it's not a hole, then done equals false. If done, so if we do end up with done equals true, then what we're going to do is say, here's what episode number it was, here's what the reward was. Okay, our goal is to get to the end goal. And so here it's going to give us our reward. So let's run this and see how this works. All right, so it ran through 100 simulations, didn't tell us a whole lot of anything, right? So if I instead turn this on, where it will actually show you the environment, and where it will tell us as we move through if we have reached our goal or if we have fallen into a hole, and we can have it show us when we, before I run that, what number of steps we do. But before I do that, what we did get out of this run is we did get that only 1 out of our 100 actually made it to the goal. So in that first simulation, only 1 out of the 100 actually made it. And so this is why I put in the matplotlib. All right, so you can see on this graph here, you can see that for the first good 90 simulations, they all fell into the hole. And then we had one person who made it to the goal, and that was it in this particular simulation. So not particularly well performing. To actually see what happens though, if we add that part that I had commented out, then when we run it, of course it doesn't like what I did to it. Probably put too many steps in somewhere. Gotta keep all the spacing that we had. Number of steps, come on. Okay, don't know why it doesn't like that. Come back to it. All right, so let's try this. Okay, so what we can see as we look at this is that you can see for each scenario, fell in the hole, fell in the hole, fell in the hole, fell in the hole. All right, and so when we look at the performance here, nobody made it to the end, and then our graph shows the same thing, that no one made it in this particular scenario. So with the random movement, the problem is that we're not learning, and after the fact, we're finding out all the routes that were chosen did not get us to the finish line. I don't know why that's not doing that. And steps, step. probably changed it to something, so hang on. Right, not sure why I have that in there. Probably because I took it from the other code I have later. I can't actually track the number of steps here because my loop is just going, is an if-then statement. If done is equal true or done equals false, as opposed to counting the number of steps. So that's why we didn't run here. So we could change the number of episodes. We're just running 100 in this case. And in the first case we ran it, it didn't actually have anyone who made it. And if we look at this one, fell in the hole, looks like no one makes it through either. So our plot is pretty basic because, you know, they didn't make it. So we want to look at in our next video is what if instead of the brute force method, what if instead we use a Q-learning or SARC to improve the process? Can we learn from it in each iteration, and can we then improve the accuracy of our process?